Good morning, ninth graders. I'm hoping you're having a blessed morning so far, and I'm also hoping that the sub is treating you well. I am also doing well, learning a lot from this training that I'm at yesterday and today. But without further ado, let's go on to the lesson today. Today, we are going to be talking about how to find the domain and range of a quadratic function. You might have learned domain and range in 8th grade, so this might be a review. But if you have not, that's okay. We can learn it together today. So let's start by defining what a domain is. A domain is all the x values that goes into a quadratic function. So that means every single x values that are in a quadratic function or on the graph, that will be your domain. Unless a domain is given, you can assume that the domain of a quadratic function is all real number. And then I'll explain what that means when we get to an example. The range is all the y values that come out of a quadratic function. So if you look at a quadratic function, it's all of the y values that are on the graph that is part of the parabola that we will see here in a bit here when we get to the examples. There are two steps to find the range. First, you must locate the y value for the minimum or maximum point. And remember, when you find the minimum or maximum point on a parabola, you look at a vertex. Step number 2. If the graph opens up, then your range, I'm going to say range, I'm going to put it as capital R. Then your range would be all your y values that are bigger or greater than your minimum point. If the graph opens downwards, then your range, again, it would be in capital R. Your range would be all your y values that are less than your maximum point. Alright, so let's look at an example. So let's go to example 1. Let's see if we can find the domain and the range here. Alright, let's start by finding the domain. And remember, the domain is all the x values that goes into a quadratic function. So if we look at example 1, we have this parabola that's opening upwards. So let's just look at, let's just start here at the vertex right here. If we start at the vertex here, we see that the x values, -2. So -2 is part of our domain. And if we keep on going, -3 is also part of our domain. Anywhere between -4, -5, -5.5, -6. And we have an arrow that keeps on going. That arrow just means that the graph is continually going to go. So if it continues going, since we don't have a big enough graph to see it, we can't see where it's going, but it's going to continue in the same direction. That means that -7, -8, all of these x values are going to be on this graph. Again, if we go to the right, -1 will be part of it, 0 also will be part of it, +1, +2, and it has an arrow as well too. So if you keep on going, 3, 4, 5, and so on. So it's going to keep on going on forever. Remember I said that we're going to assume that any quadratic function will have a domain of all real numbers. And remember, real numbers are just any value, any number that you can count. So any number that you're counting, any decimal number, any fraction number, they're all real numbers. Alright, so let's find the range of this parabola. So remember, the range is all the y values that come out of the quadratic function. So to start, let's find the y value for the maximum or minimum point. Remember, that is the vertex. So the vertex we learned yesterday was from the peak of the graph. So the graph, both if you go from the left and the right, the peak that comes together is down the bottom here. So this is the vertex of this parabola. So as you can see, again, we're looking for all the y values on this parabola. So now, currently right now, the smallest point, we started at -6. And if we continue to go up the parabola on both sides, we end up at -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. And if, again, the arrow here just symbolizes that the graph is going to keep on going. So we're also going to have 6, 7, 8, 9, and so on, and goes on forever. So as you can see, we started at our y to be -6, and then continually to increase bigger and bigger. So our range is all of the y values that are bigger, greater than or equal to -6. So again, our range is our y values, all of the y values that are on the parabola. I encourage you to pause the video and try example 2. Alright, hopefully you give that a shot. So let's find the domain for this parabola. Again, the domain is all of the x values that goes into the quadratic function, or it goes into this parabola. So let's say we should start from the vertex or the center point again. And it looks like we have an x value of 3, 3.5, 2.5, 2.2, 2, 1.5, and all of these values here, all of these x values. And if this graph continue to go, we're gonna have more and more x value that connects to it because of the arrow that signifies that the graph is gonna continually goes on forever. Again, if you look at the right, we have a bunch of x value as well too. So we have 4, 4.5, 5, 5.5, 6, 6.6, 6.7, 7, 8, and so on. So all of these x values are going to be included in this parabola. So if the graph continues to go on both sides, our range will be all real numbers. And then our range, again, let's start by locating the y value for the maximum or minimum point. Or again, find your vertex. Your vertex is where the peak of the graph is, so where both of the graph on the right and the left comes and meet at the center point, or at the peak, which is right here. So in this case, our vertex is at -3, -3, I'm sorry. So we start at negative 3 for the y value. Again, we're looking for all of the y values that make up this parabola. So we start at negative 3, and we keep on going up to negative 2, negative 1, 0, 1, 2, 3, and so on. As you can see, it's going to continually go up, and it's going to go up forever because, again, the arrow from these parabolas signify that they're going to continually go up forever. So our range would be all of the y value that are greater than or equal to negative 3.